In this video, we'll evaluate the integral of square root of tangent x plus the square root cotangent x with respect to x using substitution techniques. Let's first write down the integral we're going to solve. The integral involves two terms, a square root of tangent function and a square root of cotangent function. This problem is a bit complex due to the presence of square roots and trigonometric functions, so it's a good idea to simplify it using substitution. First, let's consider the substitution for the square root of tangent. If we set u equal to the square root of tangent x, our substitution would be u squared equals tangent x. We'll differentiate both sides to get an expression for dx. Now, let's rearrange that to solve for dx. So, dx becomes 2u times u divided by secant squared x. Remember the trigonometric identity. Secant squared x is equal to 1 plus tangent squared x. Using this identity and our substitution, we can continue solving for dx. Let's make a similar substitution for the square root of cotangent. We'll set v to square root of cotangent x. Thus, v squared equals cotangent x. Differentiating both sides, we obtain negative cosecant squared x. dx equals 2v dv. Now, rearranging for dx, we find dx equals negative 2v over cosecant squared x times dv. Remember that cosecant squared x is equal to 1 plus cotangent squared x. Using this identity, we can simplify our expression for dx. Now, we have expressions for dx in terms of u and v. Substituting back into the original integral, we split the integral into two separate integrals, both with simpler forms, one involving only u and one involving only v. Both of these are much easier to integrate than the original integral. Let's calculate these two integrals. When we simplify the first integral, we obtain 2 over 1 plus u to the fourth. Similarly, when we simplify the second integral, we obtain 2v squared over 1 plus v to the fourth. Adding the solutions will give us our result. Finally, substituting back our x terms and adding the constant of integration, c, we find that the result of the integral is negative natural log of the absolute value of 1 plus tangent to the fourth x, plus the natural log of the absolute value of 1 plus cotangent to the fourth x divided by 2. Remember to include our integration constant at the end. And that's how to solve this integral using substitution techniques.